Flexible control of stimulation parameters is an important aspect of any stimulation experiment. Our Stim Manager software sets out to do this in an easy and intuitive manner, allowing full control of our stimulation platform, the Stim R96. This video covers the complete basic use of the Stim Manager software, from setting up single waveforms, to creating more complex programs, to even operating remote trigger mode. To make some of the points in this tutorial more clear, I would suggest connecting the B and C output from the sync port on your stimulator to a B and C input on your recording system. When we first open Stim Manager, we are brought to this screen. We call this the manual mode, or single mode screen, as this interface serves the purpose of constructing individual waveforms. We will cover that function more in a moment. First, let's discuss this screen layout and some information on parameters and terminology. This screen is broken into a few sections. This centerpiece is where we will construct our basic stimulation patterns, or individual waveforms. To select which electrode this stimulation were to occur on if we clicked play, we can use this grid over here. This grid has one position for each of the 96 channels that the Stim is capable of stimulating. On the right-hand side is our log, which will display output stimulation and other important events, such as a request to display the current configuration. It is possible to save the currently configured waveform for easy loading later by simply clicking this box. I'm feeling creative today, so let's call it test waveform. After saving a waveform, those waveforms are shown up here in this box for easy access later. Finally, we, of course, have a toolbar which we'll cover in more detail later. To configure a new waveform, or what we call stim pattern, simply enter appropriate values here. Allowable entries are shown in the bottom left of the window. First, let's select whether we want the cathodic or anodic phase first. Then we can enter values for our stimulation pulse. Keep in mind that the Stim is a charge balanced stimulator. This means that the total charge, or amplitude times duration, in the cathodic and anodic phase must be equal. Now that we have our values entered, our final choices are the frequency and number of repetitions. The frequency determines the time between multiple pulses, and the repetition determines how many of those pulses should be delivered. We will put these values for here now. You can see that we have the play button available to us now. By selecting an electrode and clicking play, we can deliver a stimulation from the Stim R96. This is indicated in a few places. We can see it in the log, we can see the stimulation light on the Stim, and we can see it in our analog input that is connected to the sync output of the stimulator. Remember that a sync output is high whenever the stimulator is stimulating. It will stay high during successive repeats of the same biphasic pulse, so it is mostly used to see when a stimulation began or to know when it ended, not for looking at individual pulses. If we click play once more, you will notice that at any point during a stimulation, you can click stop to end the stimulation. If we are satisfied with our stimulation pulse, we can choose to save it for the future by clicking this plus button here and assigning it a name. Notice the directory of this file. These stimulation pulses are simple XML files that can be found here and therefore easily shared between computers or other Stim users. Keep in mind that the electrode number is not saved with the pulse. That aspect is chosen when you apply the pulse. With our waveform saved, it is time that we are able to look at other modes of the Stim, which we call program mode. This mode, as its name suggests, allows one to create more complex stimulation programs that consist of a number of stim patterns we just created. Most researchers find that they spend most of their time in program mode due to the additional features it offers for triggering of stimulation and automated control of electrodes to stimulate on. In this mode, we create programs in which multiple waveforms are loaded and applied to the electrodes that we choose for them. These programs are executed as a whole. To create a program, simply use the Add Program button here. This will open the program editor and allow us to add waveforms to a program. We can add previously created waveforms using this button. But we can also simply create waveforms within the program creator right here by entering the values manually. Now, just because we have added waveforms to this program does not mean that this is how the program will run. All we have done up to this point is supplied the waveforms that could be used in our program. To actually add them to the stimulation sequence, use these drop-downs to select which waveform should appear on which electrode, and then click Add. we can see that this waveform is added to the program sequence on the right. If you have a stimulator with more than one current module, you can perform simultaneous stimulations by using these begin and end group commands. Any waveform that appears inside of these two commands will occur simultaneously. Like many other things, if the stimulator is not able to do it, because you have too few current modules for example, then it will give you an error. In addition to the simultaneous stimulations, the program mode also allows you to build in wait times by adding a wait in milliseconds here. Of course, the wait at the end of the program won't really do anything, so let's add one more stimulation pulse after our wait. After our program is constructed, we can save it. Just like the waveforms, programs can be found in this folder and easily shared with others. Now that our program is saved, we can see it appears in the program list here. If we click on it, it shows us the types of waveforms in it, as well as an overview of the sequence on the left. Like manual mode, we have a simple play command available to play the program the number of times specified in this box. But we can also set the program to trigger based on the B and C input of the Stim using this option here. If the trigger is met, then within 3 microseconds the program will be executed the number of times specified here. This finishes covering the basics of the Stim Manager software. This tutorial covered the use of manual mode, saving waveforms, using waveforms within programs, and setting up and executing program manually or with trigger mode. With the basis of Stim Manager covered, now might be the ideal time to check out our video on StimX, the MATLAB API for the Stim. For more information on Stim Manager, the Stim, or any of our products, feel free to check out our other tutorial series, or look for manuals and white papers on www.blackrockmicro.com.